Hello, welcome to all of you. My name is Krishna Kumar Chaudhary. I am a physics faculty and my today's topic is gravitation. So let's start. Gravitation. First of all, one thing is very much clear. Who discovered the gravitation? We all know that Sir Isaac Newton in 16th or 17th mid of the 16th and 17th century, he discovered the law of gravitation. First of all, we have to find the what is the basic reason behind gravitation. What is gravitation? Sir Isaac Newton discovered. Okay, what is the basic meaning of gravitation? Gravitation is a type of force. We all know that gravity means attraction. We read in the previous classes in 9th and 10th that gravity means attraction of all the bodies towards one another. Let's take an example. This is the pen. If I free fall this pen from my hand, if I free fall it, then it directly goes towards the earth. It means that there is some force, there is some power applied on that pen or applies each and every moment on that pen. Just because of that force, this pen moved towards the earth. It means that one thing is very much clear. Gravitation is a force. Okay. It means that Sir Isaac Newton discovered the law of gravitation and derived the theory. According to the Sir Isaac Newton, in the universe, each and every object attracts another object with a force of attraction, and that force of attraction is known as gravitation force. I repeat, in universe, each and every object which possesses mass is required. Okay, each and every object attracts another object with a force, and that force is known as gravitation force. So one thing is very much clear, gravitation is a attraction force. Okay, so one thing is in my mind, that gravitation is a force. And which type of force? Attraction. Okay, always attraction in nature. Okay, so the basic thing is that one thing is my mind, there is a pen. Okay, this is first body, I am second body, and the earth is third body. According to the Isaac Newton, every object attracts another object. If I free fall this pen from this position, this pen move towards downward, not towards my side. Why? Why this is happening? That this pen directly go towards to the earth, not towards my side. This is the very simple question, because I am also a body, earth is also a body. We both applied the force on this pen, but this pen choose the path towards the earth, not towards me. It means different bodies apply different force on one another. Okay, my force of attraction is different for that pen, and the earth force of attraction for this pen is different. And which one is dominant? Towards the earth. Earth gravitational force is dominant on that pen in comparison to my force. It means gravitational force depend on certain things. Okay, it means gravitational force depend on certain things, just like gravitation force depends on first mass of the both of the body, mass of objects. Second one is distance between both of the body. There is a two bodies. First one is m1, second one is m2. There is a distance between both of the body, and gravitational force is depend on their distance also. Distance between both of bodies. Okay. Let's take an example. There is a two body. Mass of first body is m1. Mass of second body is m2. Okay. This body is m1 and this body is m2. There are two bodies. Masses of that bodies is m1 and m2. And the distance between both of the bodies are small d. Okay. So according to Sir Isaac Newton, F is directly proportional to m1 cross m2. The meaning of this line is that gravitational force is directly proportional to the product of both the masses. Okay. And second thing is F is inversely proportional to the square of the distance between both of the masses. And here one thing is very much important. Distance is always taken from center of first body to the center of second body. Okay. Distance is always taken from center to center. So from equation first and second, we can say that F is directly proportional to m1 m2 upon d square. And if I want to remove the sign of proportionality, then I have to use a constant, and that constant is known as capital G, and capital G is the constant of universal gravitational constant G. G is equal to 6.67 into 10 to power minus 11 Newton meter square upon kg square. So F is equal to G m1 m2 upon d square. This is the formula of gravitation according to the Newton. Or we can say that in the vector form, F is equal to minus G m1 m2 upon dq into d cap. Vector means magnitude into direction. Okay. In the vector form, there is a sign of negative. Negative means the force is always attraction in nature. So this is the theory of Newton's law of gravitation. So we have to take one numerical on that. There are two bodies. Mass of both of the bodies are equal, 1 kg and 1 kg, and the distance between both of the bodies are 1 meter. We have to find the force of gravitation between both of the bodies. And 1 is equal to 1 kg and 2 is equal to 1 kg. There are two bodies, m1 and m2, 1 kg and 1 kg. Distance is also 1 meter. So the gravitational force F is equal to G m1 m2 upon r square. In the numerical form, we always use this formula, and in the vector form, we have to use that formula. So F is equal to G m1 m2 upon d square. So the G is universal gravitational constant, and the value of G is 6.67 into 10 to the power minus 11 Newton meter square upon kg square. So we have to put this value, F 6.67 into 10 to the power minus 11 into 1 upon the value of m1 is 1, value of m2 is also 1, and the value of d is 1. So F is equal to 6.67 into 10 to the power minus 11 Newton. So the result is force between two bodies which have the mass 1 kg of each and the distance between both of the bodies is 1 meter. So there is a force is equal to 6.67 into 10 to the power minus 11 Newton. One thing is very much clear. The answer is in the form of 10 to the power minus 11. So it is a very small quantity. Na? 10 to the power minus 11 means very small quantity. It means the force is very weak in nature. Long range force hai, but this force is very weak because the answer is 10 to the power minus 11 Newton. So if the mass is heavier, then we can say that this force come into existence. For small bodies just like me or this marker, this force is negligible. That's why this marker will not stick to me when I free fall it. But it will fall towards the earth because the mass of earth is 6 into 10 to the power 25 kg. So that is much heavier force, heavier mass. That's why the marker will choose the path to go towards the center of earth, not towards to me. This is the question I raised in the starting of this lecture. So to prove the existence of gravitation, we have to use this formula on heavier body just like earth, sun. For small bodies, the value of F is very much less. So we can conclude this topic that gravitational force is a very low force, very weak force, but effective for a high range. Okay, and gravitational force is always attractive in nature, long range force, weak force, and depends on the mass of the body and depends on the distance between both of the body. It is discovered by the Sir Isaac Newton. Not only Sir Isaac Newton, but the credit finally goes to the Sir Isaac Newton. Okay, thank you very much. Thanks for joining the class. See you tomorrow. Bye bye.